Static analysis is for life, not just for Christmas. While finding bugs is before execution a staple, static analysis provides tools to go even further. It scans the code to offer suggestions. It provides inventories, linking remote parts of the code by their value and process. Finally, it can document the code base and keep it real-time. The best is that each mission has available tools for the job. You know Damien Seguy from the talk before lunch, so let us not present him once again. Let's focus on what he has to share with us. Damien, continue, please.
Yeah, you see, I'm an engineer. I need to restart stuff. Good. Feels better. Okay, so if you're still there after the first hour, apparently I did chase half of my audience. Or it's a very different. At least it's a completely different one. So hopefully, hopefully I'm going to also change a little bit the style because we're not going to deal with the same things. And we're going to start working on the usage of static analysis. Now, okay, there are still people coming in, but I would like to have an idea. How many are using static analysis? Okay, I'm going to rephrase the question because apparently you did not understand. Who's using PHP? Oh yeah, everyone. So you're using static analysis, right? Because basically PHP has some static analysis that's already baked in. I mean, it's basically just a simple element. And if we want to start with at least some kind of definition, you have to understand that what you call code is actually a little bit of text is at the far bottom. That's what your IDE makes you believe that you're writing well. But PHP will actually take that text and it will give it to lots of very weird named tools, and it will actually break it down into smaller elements, then organize them, and then it will reach a point where it could actually use it. And using it for PHP is only one thing, it's executing it. So we're going to go on the left side of that column, and PHP at that time, between the moment it has all the elements and knows exactly what to do with it, and the actual execution, it will actually put a little bit of static analysis, review the code that is available, and decide either to optimize it, to decide that's an error or that cannot be executed at all. It will do a bunch of things. And then it will give that to the actual engine to execute it because now it knows, it's good enough for it to be executed. So that's the point. You see that whenever you make a syntax error. Well, syntax error is probably much lower, but later when you say, hey, look, you cannot make 2 times a static in the same line, that is static analysis. It has to understand all the different elements, find them, and realize that you're trying to make a property double time static. That is not allowed, and it will say, no, I don't want to do that. So PHP is doing a little bit of it. What is usually known as static analysis, and that's like half of you raised the hand, is the other side, which is dedicated tool. The main difference at that point is that we're not going to execute the code at all. We're just going to say, hey, look, I want to know exactly all the elements, and I'm going to check as much as possible of that code before I actually give it again to PHP so it does something with it. Simple as that. And then you end up probably in code review, and you probably end up in this session because that's exactly what you want to know to do with that. What do you do with static analysis, and how do you actually end up with an audit that tells you what to do with your code and how to improve it? So the first thing that you have to be aware is that static analysis, SCA for the good friends, I would say, is everywhere, and it can start when yourself are reading code. This is basically manual static analysis. You basically look at the code, try to understand the meaning of it, use any tool you have there, semantics, syntax, organization, logic, dependency analysis, whatever, and you'll be able to say, look, this part is pretty bad, you don't do that, or we should update that to something that's going to work with the rest of the application. Other places where SCA is naturally found, on the other hand, CI, anytime you have something that's CI/CD basically, continuous integration, continuous deployment, That's where you want to have an extra set of high that will spot big problems before they reach production. PHP has some of them, and also research and development. I would even say that's probably the thing that is keeping me at the moment in the field, because beside everything that's manual use of static analysis, R&D is very interesting. For those of you who were in the previous session I had a full take a look at types and how we can actually use them in a better way than we are at the moment. This is static analysis for research and development, things that are ideas that we want to exploit or apply into our code. So that said, of course, and before we run into more details, there are lots of tools that are already available that are taking advantage of static analysis. I have here a long list of them. Of course, I started with PHP because you mentioned that. The three classic ones are over there: PHP Stan, Fan, and Psalm. But if you're using PHP Storm, and for that matter, actually, I think VS Code also has some static analysis. My good old trusty BBEdit, which has been there even before the Mac was invented, does support some language server that can display in the code findings from static analysis. PHP Storm actually has two of them. There is a plugin dedicated for that. You can see other less known static analyzer like NoVerify. Exacat is my own personal tool, so that's the one I'm working on. It's less famous than others. And there are others that are also very niche. DepTrack, PHPMD. They have PHP compatibility, as its name stands, is dedicated to reviewing the code for new versions of PHP. If you want more of them, because I have just 2 columns of 10 elements, then you can check. I have like 100 of them listed in the repository that is there. So you will find way more than you expect. Don't use them all at the same time. That's too much. So as I said, the experience I have is drawing from what I'm doing on a regular basis. I will not do the same joke about running code at the moment, but I've been working on the static analysis since 2014 when I reached Netherlands. And so lots of the elements you will see come from that experience, but also from running the other tools, because of course I have to check what the others are doing at the same time. So what are we going to look at during this hour? We're going, of course, to start with bug hunting, which is the default usage. We're going to check about training other peoples using static analysis. That's another usage that's slightly different from the previous one. And then we'll end up with documentation and inventories, which is collecting information straight from the data, from the code source, but providing it to a specific audience. So bug hunting is, of course, the obvious one. Most of the time, you come to static analysis because of bug hunting. You don't want to leave something that could be detected earlier in the code that goes into production. That's way too late. And indeed, that works very well. Just by reading the code you have over there, you will spot that there is something really wrong. Is that obvious to everyone? I see 1 nodding, so 2 nodding. I need more nodding people, because otherwise okay, good. Here it's just a very simple application of type. We have an int. We're not going to be able to access an int as a string. Maybe we could do that earlier in PHP, but that's not the case anymore. And that definitely is not going to work. It may yield an error, or it may just go completely silent. So that's one thing. We can spot patterns that will either scream at us or just be very sneaky and stay hidden for a long time until we realize like half of the application is not even used. So that's definitely one point. Of course, it's very obvious. It does make the cycle of coding a lot faster, because you immediately have a feedback saying, hey, look, this is something that makes no sense. You're not going to be able to run that in production, so don't even do that. Even though, of course, it's normal PHP code. This is completely valid syntax. Just makes no sense. Other things that makes no sense are sometimes less obvious. And this is an important one, because that means that on the previous one, you could easily apply some logic and discover that hint is not going to be an array. But sometimes it's like, where's the bug? Where are the bugs? There are two of them. Again, I'm going to take a sip, but please tell me where they're. Christian, I see you're not listening. I'm going to ask that at the end of the exam. So, what are the bugs? Yeah, the first one. Excellent. That's a good one, right? Do not use those damned letter logical, because if you would use the double ampersand as a lower priority, as a higher priority than assignation. But here, and as a lower priority than assignation. So what we have here is B is assigned to A, and then the result, which indeed starts with B, will actually be combined with C to do something. But that something will just end up being lost because there's nothing to store it. It looks like we're assigning A and B to B and C to A, but we're just calculating B to A and just dropping the rest. Again, if you switch the AND for double ampersand, that works as expected. The second one, that's a classic one that happens like 2 or 3 times a year. How do you calculate the next month? You take the date and you calculate 1 month, right? Which are 30 days later. So let's say you're on Halloween, just, randomly. You're on Halloween, 31st of October. You add 30 days and you end up 1st of December. So with that, on the day of Halloween, the next month is not November, is December. And that will happen again in January when you decide to add a month to 31 days in January, which will end up on the 31st of February, which end up very puzzlingly on like the 3rd or 4th day of March. And believe me, every single time we get feedback on the PHP.NET every year. Hey, look, there's a bug. No, there's no bug. It's just the way it works. If you go to Carbon, if you go to Chronos, you have the same problem. There is actually another thing which is like next month. It's in a full expression instead of plus 1 month. It will actually calculate the next month for you without problem, but you have to know that. And sadly enough, it's being used everywhere. So the second thing for research of bugs is that some of those bugs, you don't know about them. You expect other people to hear about them, collect them, and here with static analysis, all of that is capitalized. It's actually federated into a big library of rules. You run one tool, maybe PHP, PHPMD or whatever, and they will apply a number of those rules and say, oh, look, I found this pattern. You probably have a bug here. Now, it's very interesting because I wanted to take a look at, and compare, for that matter, the different tools that I've mentioned. And the numbers of rules are widely spread. The worst, or the one that has the least number of rules, is PHPMD, although it's not also the most recent tool. And I managed to count 45 rules, which seems a little bit low, right? It doesn't seem like it's checking 45 of them. I could not find anything on PHPStan, although I think they started documenting it recently and have actual names. But by asking Andre, he said, no, I don't really know how many of them, because when we spot something, we raise an exception, but there are many ways for that exceptions to be raised, so I can't really tell you how many times that represents a rule. It's just like you have an exception, you've got a problem. Psalm does have at least related documentation, so it's easy to go on the website and check that. On the other end of the spectrum, I realized that I wrote myself 1,700 rules just for execat. So beside the number and the fact that I'm usually very happy of myself when I see that number, there's a wide range of meaning for whatever you're looking at when you're using a static analysis tool. They may have different level of intensity and different ways of searching things. And I would like to illustrate that with how we create a rule. So that's going to be very different from what Dave they did a few days ago, like the workshop of writing a PHP stand rule. But we're just going to look at the content itself. Most of the time, a rule starts with what I call the poster boy. You know, it's like, how do you advertise them? Everyone knows about the problem with str-pos. Do I have to explain that again, or you're familiar with that? You know, it's like when you're looking a string inside another one, you end up with an index that is 0, meaning that the string has been found inside the other one at the very beginning of the string. But if you do not compare that to false, then you're going to think that the string has not been found because you're confusing false and 0. A very classic one. Does anyone know how many other functions behave the same way than str-pos? 1? Sorry? str, that's another one. I don't want the list because it's going to be a lot of things, but that's definitely one of them. There's a bunch of them which are with eyes for case insensitive. There's another bunch of them which have an extra R. There's actually 26 other functions which are behaving the same way, the worst offender being pereg match. If the regex is wrong, it will return null. Null is going to be confused with 0, and that's going never to work. But as I said, str-pos now act as the poster boy. So I just mentioned str-pos problems, and you should be able to understand what kind of problem is there. So let's do a very simple exercise, and I need your participation for this one. How would you detect a dead function in an application of PHP, a PHP application? What is a dead function? Obviously, it's a function that is not called, right? So how do you do that? So that would be a little bit further. That's good. That would be one. But at least you're going to say, hey, look, I have a function foo. I do not find any call at all of it, right? No call. That's probably a dead function. Now, there might be a bunch of specific cases, but we're just going to consider that we have the master of that part, like dynamic function calls. That would be a special case. But then I will say this is not the only one. Beside the functions that are never called, which are the dead function in a PHP application? Again, we're going to stick with PHP with functions because it's easier, you know, mentally to search. We could do the same thing with a method, but that just gives a lot more cases, so we don't want that. What else is a dead function if it's a function that is not called? Oh no, you can call a function without content, that's fine. It's still pretty useless, I agree with that, but then it's not a dead function. You can, you know, RFU, like reserve for future use, so that would be fine. No. No, simpler than that. You don't have to go further. What do we have? We have functions that are calling each other and functions that are dead. So the next function that is dead is a function, if I can move, is a function that is calling a dead function. Right? I mean, the second is dead. The second is not dead because the first one is calling it. But the first one is never called. So a dead function calling a function is still going to kill it, basically. This is what I call the propagation of death. It's contagious, apparently. But that's a problem, right? So if this is how you run your static analysis. Hey, how many do I have dead functions? You have 3 of them. There they are. I remove them. How many do I have? 0? No, 12. What? Yeah, because they were calling each other, and now there's some of them that are gone. Yeah, you have to dial it again. So you see, the complexity is important, and also it's not finished. What are functions which are not called by another dead functions, but are still dead functions? It's like a layered cake. You know, you have several layers. You have to go deeper. No? No, we would have spotted that already. We need to find something that is not a dead function that's calling a function that's, in the end, is a dead function. Well, it's very simple. It's a recursive function. Because a recursive function is going to call at least itself. So the important here is that if for the recursive function to be dead, it's not that it's not called by itself. It has to be called by someone else. So you have to check other calls and make sure that the one that is calling is not yourself. Which means that we can go to the fourth layer, which is those recursive with higher levels. It's like when you have A calling B, calling C, calling A. Which means that the size of an application, you might have to actually check all the functions in a whole circle. If you have 200 functions, you'll have to check if they do not make a gigantic circle of life or death, for that matter. So you see, we started with a very obvious problem that probably, is the poster child. Of course, a dead function is not called. That's simple. We might discuss about what is a function call, because it might be actually dynamic call, or it might be called through a remap, that the function name is actually inside a string, or it might be stored in a config file, and we never actually see the name of the function, but it's configured somewhere else. Okay, there's different ways and limitation. But there's a bunch of situations where it can also be a rule that goes really deep. And of course, checking that all the functions are not cyclically calling themselves, is a way different thing than just checking if one function is called or not. So first we have this depth, and then once you start deciding to use one of those rules, saying, hey, we don't want any dead function in our call, you end up in what I call the discussion of the extremes. There's usually some people who are extremely for, and others who are extremely against, and somewhere in between there's the common case. So you can start any subject that will raise a polemic, because that's going to be good. We could go with final. I will go with else. Don't use else. It's bad for your code. And then what happens? Of course, you have to bail out early. That's the poster child of not using else. Okay, you do something, check it's wrong, just return, and that's it. No need for else. Of course, on the other hand, if you want to say, I want to start my Fibonacci with a 0 or with a 1, then maybe the else is going to be important there. You need to write it. So you end up with the other case. And then what is happening? Well, it's that the continuum is broken. You cannot just apply else, removing else everywhere blindly, because you're going to have all those discussions in between. And probably not deciding is still deciding. Nothing will happen. And it will stay there. But anytime you want to do that, then of course it's going to reignite the discussion. So that's important, and we even added the problem which that the static analysis tool might detect the situation, apply a different level of analysis inside the rule, and end up with different results. They might not find the same thing. It's actually pretty fun to find those very simplistic rules and run that out of the 5 or 6 elements, static analysis tools. They will not give you the same results. They do not have the same way of searching things, they don't have the same depth, and then they don't return the same results. If you have to choose one, okay? Stick to it, it will do good to your code, okay? Don't look the 6 of them just for fun, because you're going to get crazy. One is sufficient. Once you're done with one, you can move to the other one. Okay? So the important here is defining the thing that you want in your code. So as I said, you have this opposition of or discussion of the extremes, and sometimes it's not even a bug, it's just features that you don't want to use. And for that, static analysis is good at finding the usage. Like, do you use Goto? No, there's not enough people in that room actually to use Goto. There would be like 1 or 2% of you. There's one guy raising their hand? No? Okay, good. Oh, 1. Okay, so there's at least 50 people in that room, because there's like 2% of projects that are using Goto, so that kind of checks out. But maybe all the others will decide, no, we don't want to do that. This is forbidden, maybe for ideology reason, maybe for just previous experience. That's fine. It's still a feature. You can't actually remove it from PHP. So what you might actually end up is saying, I want to evaluate or check in my code that this feature is being used, and then when it is, then see if we can actually remove it. Okay? So it's slightly different from bug hunting, because this is not a bug, this is a feature. There's just no way to remove that from PHP. If I remember correctly, there is at least 2 configurations which allows you to forbid usage of specific PHP native functions. I don't remember the name. It's like function disabled and class disables, that's it. But it's so slow that usually people just immediately remove that. It's like, it's there, I'm not going to remove it, but don't use it. So you have to use static analysis for that. And defining the values in your code means that you have to know that you don't want to use else, but you also have to translate that in all the workarounds that there are. Because the first one does not show any else, but there's pretty much a else for me. Just that you don't see it. It's like the A is defined first, and then there's a if a condition, the else is just not written. Also, if you want to use ternary conditions, you're not going to forbid the usage of column because the column is the one that's telling you that it's an else, right? So you have to pay attention to the variations, and if you do not have a feature that is allowed, probably there will be someone who's trying to do a specific workaround, and the workaround may be worse. So in general, I do end up with two different levels of rules and see if we can decide the one that are important. The first one is what I call syntax level bugs. And syntax level bugs is when you can basically solve the bug inside the piece of code you're looking at, okay? It's basically a one-liner. It might be, of course, more than that. It might be rewriting a bunch of methods. But if it's close enough and it's easy to refactor, it's fine enough. And then I usually put that directly into the CI, because then when the CI breaks, I have something that is also fast to spot, fast to fix, and then I can actually train the whole team around it. The other one is a little bit higher, and that's, again, the session we had an hour ago about more conception-level bugs. The fact that you have organized the types and the classes in a specific way, and if you want to fix that problem in particular, that's going to be a much larger problem. Now, on this one, while syntax bug is just a question of collecting them along the way and just listening to whoever run into that kind of specific bugs and making a rule for it, that's just capitalization. Everyone is contributing by running into the bug and explaining how they fixed it. Conceptions level, we probably as a community still looking for the tools to organize that. There's a bunch of them. We can, for example, tag classes as being services or entity or data values. There's a bunch of references like that, but the way that we organize those classes one versus the other is still pretty much unknown, and that's where research and development needs to be working hard. We need to have at least vocabulary to organize that, and then from there we can build some rules and go further. Again, this morning Dave presented things like seals, friends, which starts to crystallize the different relationship within classes. There is this class that does not allow more inheritance than a few classes, or does not allow calls from other specific classes. That's already a good way to restrict what is currently a completely unregulated freedom. And basically everything is possible. And that's probably one of the main scourge of the current code. Now, another scourge of the code is that sometimes we need to teach people to do stuff. And the nuance between bug hunting and suggestions is pretty thin, actually, because it's at the tool level the same. Who's aware that array keys has 3 arguments? Yeah, I probably told you myself. Array keys is that famous functions that will list the keys of an array, right? You give it an array, just list the keys. Why does it need 3 arguments? I mean, I don't know if it's why. I mean, someone decided they needed 3 arguments. The second argument is a selection value. So if you give a second argument to array keys will return the keys whose value match the one you gave as a second argument. Think about it like in array, but it will return every single element whose value is the value you pass. So here I have the for each that's doing exactly the same as the array keys. It's looking for the values that are 33. The third argument is just a question to ensure that it's an equality, a type equality, or just a relaxed standard PHP stuff. How much of that is a bug? It's not a bug, right? It can stay in the code and be available and be reusable, And everyone understands that. And if half of you did not understand array keys with three arguments, they would probably not be surprised by the law for each. Well, they would probably be like, hey, what the hell? How many arguments do I need there? But then that means that you have here a little bit of training. Remember those bugs that were based on our ignorance of PHP, precedence rule? Well, here we have something that's close enough to it, but it's more like we need training. We need the whole team to understand that, because if there's at least one of them that do not understand, they will probably come back and say, hey, I don't understand, why do we have that? That's going to show off in next code review. It might also be, and that's a really classic trap, just PHP new features, right? Everyone is using what, PHP 8.4 at the moment? Oh, sorry, that's just me. 8.3 already? No, it's next week again, so 8.2. Right? How many of you have checked that the feature of 8.2 are actually in use in the code? No, you don't, right? You don't care because you don't have to. The code was working before. When you migrate, the main problem is what? Well, it's just backward incompatibility. Things that do not work in 8.2 that worked in 8.1, for example, and there's a bunch of them. Okay, good. But once you have moved to 8.2, do you actually take advantage of things that 8.2 is providing? No, you don't have to. It still works. And, business will come and say, no, we need new features. But you're still building some depth. It might be nice to have static analysis that comes and say, hey, here is a bunch of suggestions. You use a lot of those constructors. There's promoted properties nowadays. If you have time, just decide to use it. Just normal training. It's going to help you do something. And you don't have to do it. You just decide it. How does that work when you have I would say, a native PHP feature that you don't know about? Well, you're going to do exactly what we did in the first code, right? You're going to write a workaround, the for each. And then either you don't know about it, or it feels like you learn something more, and then you're going to fix that workaround by doing it another one, and maybe fix again. Or in the process, you will learn something that says, hey, yeah, of course, you can replace that whole loop by array keys, and that's it. I should actually mention that there's not just one way. It's really like, it's a PHP way to do it. There's like a native function for it. It may be several of them, but in the end, usually when you're there, you do not move anymore because you can't go further than that. In between, there's a whole process of learning that can actually be done by reviewing the code together and having someone who says, hey, I know there's a feature that can be useful here. Now, the most important I said is that we need to have the whole team understand it, and that goes straight into defining your own values. So the way I do that is around suggestion workshop, because the most important is that everyone is on the same page and we don't have those, hey, what the hell is that in my code? So you look at one static analysis tool, get one of the suggestions, and see with the whole team if we understand it, if everyone knows about it, and if there is some kind of consensus about using it, okay? If there is, again, one of those battle of the extreme, just ditch it, forget that, that's not worth the fight, move to another one. There's usually a long list of them. So feel free, you will not run out of those in at least a year. So by then, PHP will have new versions, and you probably can do that again. And while you're doing that, since you're discovering the things, everyone is now up to date with this new value, this new rule, well, you can fix it immediately in the code, because that's immediate application. Hey, here is array code, here are array keys, I can use that in different places. Do I work well? Do my tests here run? Everyone is agree, is it well done? And we're all on the same page. Then we make that into our new value of coding, and then we move to the other one. Everyone is trained, everyone is on the same page, and you're improving your code. That's definitely a good hour. And if you don't want to use anything in terms of static analysis, the basic one I would suggest is just to run the linting of PHP on your current code. You're stuck on 7.4? No problem. I mean, too bad for you, but you can still lint your current code with PHP 8, 8.1, 8.2, 8.3, 8.4, because it's already available. I mean, RC, but... And check the warnings. What you have here is the number of distinct warning messages that are available inside PHP binaries per version. Okay? You can see that in PHP 5, sorry, it's a bit small, but I'm close enough, I can read it, so that's good. We had like 250 different error messages in PHP 5. Now, at the other hand, 7.4 is the one that is returning the most number of error messages, and we have like almost 900. At the moment, you can see that it usually starts low, goes up, until we have a change in terms of major version. So from 5 to 7, boom, we have a few of them. Why? Because a lot of those deprecation notices goes away. They are now turned into definitely a fatal error. So no need to have warnings anymore. And then, again, from 7, we start deprecating new things or changing ways or changing behaviors. It piles up, boom. So given the current track, I think we're slowing down. So maybe we're reaching a point. Maybe next year, by 8.4, we'll have a huge number of new deprecations, and that will go away for 9. I tried to push the PHP group at moving to PHP 9 this year because we're running out of Elephant, but they say Elephant is not a reason for PHP 9. I really don't know what's a good reason for that. But just use this one. That's your static basic analysis tool. It will detect initially, for example, all those undefined properties that you've heard about since PHP 8. That's going to improve your code. Anything that improves your code for next PHP versions will probably improve your code even if you stay on PHP 7. And now that we're done with bugs, with things that looks like bugs which are not bugs, we're going to look at something that is scattering your code, that is scattered in the code, but that is definitely not bugs. And I call that code inventories. So code inventories is when you collect one type of thing in the code that is usually very scattered, but for the first time they are all together in one place. And there's a good number of them. That could be, well, you can go with cyclomatic complexity because it's just a ratio, so that's a general one. But if you know about magic numbers, you know, those numbers that are used somewhere in the code and you don't know why, well, maybe you want to look at why is there so many 732 numbers that are used all the time in your code. Regex is also a very good example of things that are built when you need them. Because, I mean, you are able to type pereg match, that's good. You're not going to ask anyone to write a regex, right? You either copy-paste it from ChatGPT, that's the modern way, or you reinvent it yourself, and you end up with all those regex all across the code base that are basically doing the same thing. And to be honest, I actually wanted to have a list of them. I went not further than my own code. So this is extracted from Exacat. I thought, yeah, I can show something that's good, and it was not that good. The first thing is you can see I'm not even consistent in my delimiters. So there is the pound here. Most of them are slash. I usually like 2 or 3 of them, but I'm already not consistent. But I also found that there are some of them that are obviously rebuilt. Why do I need that one? It looks like a date. With the dot, it's maybe a version system. But that looks suspicious. Since I wrote that slide, I haven't taken a better look at that, so I'm still a little bit clueless about what I even wrote myself. The last one also makes really little sense to me. It's strings and numbers separated by a column 8 times, so it's very persistent, but I don't know what it is. It's probably worth taking a look and understanding why it's there. And if it's scattered about in different classes, maybe that would be some kind of utilitarian function that is common, and I just have it once, but I know that everyone is using the same. And you can do that with lots of other things. The other things I like to check is what I call favorites. And favorites is when you have 2 different ways to do the same thing in PHP, and then you do. The first one is very simple. It's when you do a new, either on just the name of the class or the name of the class, the parentheses. Okay? Of course, you need to be able to call that without any argument, because if you need an argument, you need the parentheses. But most of the time, you might have the 2 of them. There is one which is a bit harder for static analysis to understand. The other one is pretty fine. And here we can see that 100% of the application, like almost 40,000 calls, when they do call, they always use the name with the parentheses. When you have something that is that high and 100%, it means that they do have static analysis that does check that everyone is doing the same way, which is obviously not the same case for the new line. New lines, you can do them at least 2 ways, /n, or using the concatenation of the pereg, the PHP underscore EOL, end of line, constant. Pretty much the same. But here you end up with something that is like the jury is still out. No one really knows. There is a tendency to use /n more often. And sometimes they do a third of the time use the constant, but obviously there's no side winning the war. I usually consider that if you go down to 90% of one of the two parties, it's sufficient to decide that this should be the standard, and probably it should be enforced one way or another. Basically, everyone agrees. There might be a little bit of history, a little bit of legacy that still needs some cleaning, but that's it. Regex delimiters, it's a fun one. You can see obviously that / is still dominant, but there's how many of them? I don't know, 12 or 13 of them. It's not big to replace them and make them consistent. It just gives a little bit a different feeling when you're reading the code. How many do you think I have as favorites? Here are 4 of them. I probably can fit more on the screen, but I do have like 25 or so of them. There's a lot of number of things that you can do in 2 different ways in PHP. And if you do, then if you don't keep them and monitor them, that's going to be half and half. Probably 2/3, 1/3. So the field at the end is a classic. Another one that is an interesting vocabulary inventory to do is the vocabulary. Now, for those of you who are familiar with DDD, that's basically close to the ubiquitous language. You're using something. We're going to look at, for example, only the parameters. We could go very wide and just look at variables, but parameters do hold a different meaning, right? Because parameters are the one called in the method signature. So they don't have exactly the same meaning as a local variable. So you can look at all the signatures of everything, method, closures, whatever, and collect all the top 5 most often used names as parameters. And I give you 5 different top 5 with the name of the framework or the application below. And I think that's very interesting. You look at Symfony, the request, so a parameter called request only appears number 5, and it's still a framework. What does a framework do? It literally grabs data from the HTTP request, prepare it, and then there should be a response somewhere. I don't see that at all. On the other hand, I do see messages. I do see values and options. So we are basically configuring things. I recognize you're the brother of the other guys, right? So it's not the vocabulary I expect from a framework. On the other hand, you look at WordPress, request is now number 2. What do we also see? We see post. What does WordPress do? It basically manages articles, and it calls them posts. So this probably is the first vocabulary or word that makes sense. The rest is key, args. I love this one. I mean, what do you have? I'm getting an argument. What's the name of the argument? It's argument. Okay. Contao is again a framework, a Brazilian framework. Request is number 1. So obviously, if they do something, they just deal with HTTP. That's fine. Which probably means that here, Symfony being very low with the requests shows that they're doing much more than just processing requests like that, and they probably have other elements and components. Same stuff. You can take a look at Rector. Rector is allowing you to replace code and mass update in your code. Would you guess that when you see the name of parameters over there? They have nodes, expressions. I suppose that's the usage of exp, type, class methods, and class. there's not a single clue of what they're doing looking at those parameters. And I think that should be, visible, because that's their actual, business model. Carbon, again, Carbon is a date manipulation library. There's not even a single word of seconds, minute, day, or year. The first one is argv. Anyway, so we can take a look at those. This is already, very interesting. We're not looking for a bug. We're not looking at educating anyone. But we're just trying to see if there's a trend in our code that might be interesting to see. We might end up with a conclusion. The one I gave was very superficial. But you can still learn something by looking at that. You can also consider two different things. We've looked at the most frequent names. So that's the first part. In the middle, that's the one that are the most commonly used. And I would suggest you also take a look at the long tail. So I don't have that, because the long tail is those parameter names which are the least used. Why are they just used once? It might be useful for that specific method. It might be a typo. It might be someone who didn't know what to do and just decided to, fuck it, make it x1, that's it. But it could actually be something like, I don't know what to do, I just give it a strange name. I had an address book who had parameters called unknown from 1 to 10. I mean, it's an address book. You don't want to have unknown, you want to know people, right? But they still had those. And that was interesting to see that this part of the code was pretty badly named and the rest was going along. So take a look at the two of them. In the middle, this is basically your business, your bread and butter, so that's the thing you use the most. You might find tools for extracting more ubiquitous language from there, like a dictionary or a glossary that tells what you're doing every day. And I'm going to finish this part with the document. So again, we moved from bugs to suggestions to inventory, where we now just search for tracks in the code. And document means that we're going to give that to someone else who needs that. A very classic one, because we can't do document like that easily, is just the exception tree. And the exception tree is, again, one of those situations where you don't know what to do when you need one, right? You know that there is a problem because you have a null value, you can't use that. You're going to throw an exception. Which one are you going to throw? Probably an exception just like that, no name, but a message. That's already pretty bad. Then you think, okay, I'm not going to put a message, I'm going to give a name to that expression because it's already an improvement above just a message. But then you end up with things that are organized like that. PHP is providing you with native exceptions that should be used and reused, but you don't necessarily know of that, and you also probably have to discuss who is the best one. You can see that there is a class file not found as an error exception, which is by itself pretty fun. And then just above, there is another one which is called file not readable. So apparently, they don't have the same level of processing. And when you want to be coding and you think, okay, I need to create a new exception, well, first, keep it next to your component because you don't want to have one folder with all the exceptions. That makes little sense. But you may want to have this automated documentation where you have the list of exceptions and the way they are organized. You may realize that, in fact, there's already another one that can cover that problem. You have already another one existing, and you're not going to reinvent a new exception just for the purpose of that. You could probably think about reusing the one that's there. Now, instead of looking for the code, and that's documented as a simple tree, then you now have a better way to do reusability. Another documentation that I always find interesting, that at least I do for PHP itself, is taking advantage of usage statistics. We often hear about those new features added to PHP. Next week, we have PHP 8.3, so we're awash of new features, behavior changes, things like that. The question is, how much is that actually used afterward? We never hear about that. So here on a specific application, I mean on a big corpus, of PHP application, I tried to keep track of how many times, for example, spaceship has been used. For those of you who were there at the time, it's still like 5 or 6 years ago, I guess. PHP 7 introduced the spaceship operator. well, ever since we have everything. We have the TIE fighter operator, you have the battleship operator, and we have a Death Star. So if you want to look for that, please Google it. There's a zoo over there. But Spaceship was touted, was the media darling of PHP 7, and 7 years ago, it's like 5% of usage. I mean, I don't want to remove it. That would be useless. But maybe we should have been paying attention more to other features. On the other hand, promoted properties, which just appeared in PHP 8.0, are now used by 15% of PHP code, which is still low. I mean, after 4 years, that should be expected to be a bit higher. But in the same time, it's much better than Spaceship. Spaceship was maybe not needed. Or at least it's just catering for a niche of the audience. Then you can take a look at those. We can have even a top 100 of the PHP functions. If you want to make sure that you're a PHP developer, maybe you should make sure that you know all of them. I would just give you a hint. PHP array keys is in that list, and you need to know all the arguments. Now, beside that, of course, you can do that for PHP, but what happens if you want to do that for something specific like a framework? And that could be your framework, or that could be the framework you use. So you might be using Leaf, or Concrete 5, or anything more famous. I guess you can find other names. But what we've done precedently on looking at the features of PHP, why is it? It works because we already know the different references. We know all the new features version by version. It's easy to spot that in the code. Only just if it was only for backward compatibility and making sure that people do not make incompatible code, that would be fine. For frameworks in general, and for that I will just call that component because it's very generic, well, the main problem is that the lists of available features, classes, method, functions, argument, whatever you are, is gigantic. Symfony is just like 2,000 classes or more. It's like 13,000 of methods. That's a lot. And of course, from version to version, it's changing a lot. So we can still do exactly the same. Here is a list of PHP, of Laravel functions, not classes, functions. There's not too many of them, so it's a lot better to fit on the screen. But you can see the way they are used, and that starts again as an inventory. If you are using specific configurations, all of those calls will help you make sure that those should be documented because they are used in the code, they are available, you can put them there, and that probably should be in the documentation. Now, to finish that, this description happens to exist as a format that I created that is useful for static analysis. Because if you want to analyze, let's say, a WordPress plugin, you want to analyze, I don't know, a few hundred files. You don't want to also bring in the whole WordPress document because it's a gigantic framework. So it has lots of them. And here we can actually use this JSON file to describe how actually WordPress, I think the example is not WordPress, it's more Laravel itself again. That describes everything in detail without bringing in the code. You don't have to reanalyze it again to know exactly which are the methods that are available because everything is stored in a hierarchical way. So you have the version, the method, then again, the namespace, and then after you have all the different structures, and it's extremely leafy, but inside the classes you have the method, the constants, inside the method you have the parameters and all the abstract elements. And all of that is made for static analysis and also useful for it. So, as a summary, what have we checked in terms of usage? Well, bug hunting, because that's the most bang for the buck that you have, and that's important. Coaching is definitely a good way also to both leverage static analysis and improve your team. And it's not just looking for bugs, because that's not our life. We also want to improve and be happy using new features. Inventory documenting is a side thing for which you need a little bit more time, but that automates some of it. Not all of it, but it does automate a lot of it. So that's very good. And of course, you can end up with research and development. And research and development start with my favorite tool, which is SCAM. I just let you, understand the English word first. But static analysis, static code analysis and modification. Basically, Rector. Well, it's not the only one, but so we now are able to use static analysis as a base to decide what we want to change in the code and do that en masse without any supervision. PHP CS Fixer, I think we have Greg in the conference somewhere. So if you want to bug him about pushing your code and white spacing it correctly, he's the guy to talk to. Adding features was again a presentation from this morning. So well, you can go on Dave's website and learn about things. I think you can also go further with things like test generation, because describing the way the code works may also entice you or help you structure the way that the tests are going to work. I was thinking, for example, whenever you want to test a private method, well, you can't really reach it because it's private. But with static analysis, we can find that this private method is called by 1, 2, 3 public methods. So you should start testing those to manage to reach it. Again, static analysis can just check the code and tell you, hey, look, here is different ways you have to reach that method. Give it a try. And that's it. That means that I may be back next year with a lot more things to explain to you again. Thank you very much. I have no idea if it's open, but now questions. Who wants the cube? No? I want to throw that to someone. Karim. No, you don't need the question. You just, I just wanted to throw it.
It was nice. Thank you.
Thank you very much.